before we get our speaker today to come up to share with all of us, just going to find out where you guys are coming in from. So just help me by putting in the chat. Okay, got it. Okay, tell me out by putting 1 if you're coming from JC, 2 if you're from Poly, or 3 coming from any other place apart from JC or Poly, maybe international. Do we have any international students joining us today? All right. All right, cool. All right, everyone is responding. Finally, I see a 2. That's awesome. Okay. Okay, maybe just a bit more time, just a minute or 2. All right, and as I was saying earlier as well, do not feel pressured to turn on your camera. Okay, you do not need to, but do engage with us on the chat options and the functions below, as well as the reactions. So if everyone's feeling good, you can give me a thumbs up. All right. Let me just see whether you guys are still with us. If you could, just help me to give a thumbs up on the Zoom reactions. All right, I see some of you. Very nice. Okay. All right, so without further ado, I think many of you guys are already checked in. So I just want to, at this point right now, introduce our speaker for this morning, Ping Fong, or Prof. Ng. It's our assistant professor with the School of Mechanical and Aerospace Engineering at NTU. He's also the deputy director for the eVTOL Research and Innovation Center at NTU. He received his PhD from Imperial College London from the UK, and he's actually our homegrown talent right here from NTU, graduating with a Bachelor's of Engineering Honors from NTU. So today, this morning, we're very privileged to have Prof. Ng share with us. So Prof. Ng, please.
Thank you very much, Elijah. So, very good morning, everybody. Very glad to see most of you guys here. Allow me to share my screen. Just give me a minute. Okay, is there supposed to be a screen sharing somehow? Give me a minute. Speakers view. Okay. You should be able to see my screen now. Okay, that's great. So do let me know if, say, for instance, you're unable to see my screen. First of all, as Elijah have introduced, I'm Ping Fong, so you can just call me Ping Fong. Any questions after this talk, any time in time you want to ask anything about aerospace engineering, feel free to ask me. As Elijah introduced, I was a aerospace engineering student many years back. Graduated, then subsequently I went on to work, and then I went on to do my PhD and did a postdoc, and then now I'm back at NTU as a prof. So I've been at NTU for almost 6 years, 7 years, actually more than that, because my postdoc was actually done in NTU as well. So hopefully I'm equipped with sufficient information to actually give you guys a good background of what aerospace engineering entails, as well as what you guys should expect, so that you can make a informed choice today. Okay, not necessarily today, but an informed choice in terms of what you plan to do coming up. So first of all, I think you guys are here. You have a question of what is aerospace engineering. I think that's the first question that you guys have. So many people have different expectations, or people think differently on what aerospace engineering is. I think your parents are very close to you, definitely, and they will have a certain expectation that aerospace engineering, it's university. So pretty much you go to university, you sit down there, you go there, listen to classes, you attend labs, you get to make friends, you get to fly drones, you get to know people of the opposite gender, you see they're happy talking. So that's what your parents think you will do. And what if you were to talk to someone like a stranger, maybe even your neighbor, they would say, hey, I'm going to study aerospace engineering. They will say, wow, you're studying space. So you will go to space one day. Okay, so probably that's what they will perceive what you will be doing. And to your friends, you said, hey, aerospace, they say, wow, you become a pilot next time. Will you be, will I have a chance to actually sit on the aircraft that you'll be flying, so on and so forth? Uh, so that's the impression that probably your friends will have without knowing much about aerospace engineering. And what other majors will think? So say, for instance, if a student from um, Triple E or probably from civil engineering or bioscience, they'll say, wow, you're studying aerospace. You must be very smart. You must be solving very deep equations. You must be studying a lot. You must have known a lot of things about quantum. You know a lot of things about all this physics or the mathematics and all sorts of things. Okay, so that's what other majors may think. And that all make you think you can fly. So this is what you end up to think you will do. You end up to be flying. But the main question is, what do I really do? Okay, what do you really do as an aerospace engineering student? And eventually, when you graduate, what does the industry provide you? Or what is the opportunities? Or what are the opportunities for you if you have an aerospace engineering degree? So this all boils down to what we actually believe, or rather what we are able to provide to you as a school. So in the aerospace engineering course, we seek to do three things. Okay, in fact, beyond three things, but let us just zoom into the three things. The first thing is to provide you with the fundamentals, engineering fundamentals. Fundamentals when it comes to things like physics, mathematics, um, core soft skill sets, and all sorts of things that actually enables you to become a successful engineer, successful person, successful professional next time. Okay. Now, I must highlight that the fundamentals that we train you, they are what we call the engineering skill sets. These are the core skills. There's also the skill sets which are more towards the common core. Common core meaning to say those are skill sets that enables you as a individual for any career out there. So say for instance, eventually you want to switch career or you want to explore certain things, we'll provide you with the necessary skill sets to enable you to move into that. So these are the fundamentals to train you not just as an engineer, but as a working adult, but as a professional next time. We'll give you industry relevance curriculum. So our curriculum, it's actually vetted by industry professionals. So you may not know, every few years, in fact 4 years, we have an industry alignment panel. In fact, most courses, in fact, all courses in NTU have that, is that we invite CEOs, we invite um all the key personnel from industry to come down and they review our courses. And then they will say, hey, so and so course is probably no longer relevant to industry. Or probably there is this course that is probably more relevant that you should introduce to the students, and subsequently they can actually go on to industry and they will be more useful for them. I give you an example. Last time when we first started, we did not have MATLAB, but we took on the advice from the industry and said, hey, students need some coding, students need some MATLAB. This was many, many years ago. Even before AI, all this data science came in, they said, industry already felt the trend. They said, hey, NTU should do that. And we took it up. And subsequently, we had this course about MATLAB, about Python, about computing introduced to our courses. We also take your fundamentals and then we let you apply to different areas. Okay, so say for instance, if you learn heat transfer, we apply it to the engines. If you learn materials, we apply it to the aircraft materials. If you learn fluid mechanics, we apply it to the aerodynamics, so on and so forth. Okay, so these are the core things that we actually will provide you should you choose to join us. Now, these are the courses that we offer. I believe most of you guys should be aware that, or rather, you are already aware that you're hearing an aerospace engineering talk. So we offered various forms of the degree. The first one is actually the aerospace engineering degree, and this is really just aerospace itself, a very niche course, a very focused course into aerospace engineering. The next course is aerospace engineering and economics. This is a double degree. What does a double degree mean is that um, for aerospace engineering, you study around 130 plus AUs. For this double degree, you study around 170 plus AUs, and then you graduate with 5 years, sometimes 4.5 years, 5 years. Okay. For aerospace engineering, for JC, this is 4 years. For poly, that is 3 years. But for this double degree, that is 5 years. Aerospace engineering with a second major, this second major would mean that you take some of the electives that you're supposed to do things like business, anything. You can choose any subject that you want, but then just focus it only on business, entrepreneurship, data science, as well as sustainability. Then you have a second major in this area. Then you also have aerospace engineering minor. That means you also take the electives, but less amount electives to go into business. Okay, so these are the few courses that you can take. Now, should you choose to do, say, just aerospace engineering alone, we also allow you to do a specialization. Now, by doing specialization, what it means is that in your final year, on your third or fourth year, you do more courses. You do more courses or rather, you switch your courses, you choose your courses that's focused in a specific area. Then you do a specialization. That means in your degree, you will show that, oh, you have a specialization in a certain area. So the specialization that is available includes autonomous systems. For instance, if you like robots, for instance, if you like drones, you like automation in manufacturing, um, energy and the environment, sustainability, mechanical engineering. You'll be surprised that we offer a specialization in mechanical engineering. The main reason why we offer this is because some students have feedback to us that they would like to do become a professional engineer, a PE. So a PE in industries allows you to sign off documents, meaning to say that you're the one to certify a component is safe for use or it's um I would say is certified for use. So these PE professional engineers, every document that they sign is being paid. So it's additional revenue for them, and it's actually a very high status when it comes to the engineering field. So some of them wants to be a professional engineer, and they will require a specialization in ME in order for them to become a professional engineer. So that's why we have this specialization in mechanical engineering. We also have smart manufacturing and digital factory. So this talks about how you can automate the shop floor, how you can actually produce things that is in the industry 4.0 context. Systems engineering, more towards looking at the broad view. How do you actually encompass every single thing? So say for instance, if you talk about aircraft, an aircraft involves the engines, involves the controls, involves the aerodynamics, involves the structures, materials, all sorts of things. But individual components, how do you join them together? How do you actually make sure that they work cohesively? So that's where system engineering comes in. Okay, so these are the few courses that we have to choose from. So a lot of variety that you can go for. Now, this is roughly a syllabus that what students will be exposed to. For aerospace engineering students, you will have around 135 AUs if you're admitted to year one. So you have a JC student, you're starting for year one. You will do major requirements. This blue color pie here, this is actually all the fundamentals in aerospace engineering. For instance, your aircraft design, aeroelasticity, aerodynamics, propulsion, everything you need to know about aerospace engineering. Then subsequently, this 13% is common core. Now, this common core talks about things that is more making you better as an individual. This common core is across the entire university that students study the same subjects. For instance, we talk about healthy living. We talk about sustainability and the environment. We talk about aging in the society. So these are more towards common topics, or rather things that we see in the society today, things that we see that is happening today, and then we let you get exposed to it. We train you in terms of the ability to analyze things, ability to uh, come up with solutions, propose solutions, and make you a more well-rounded and informed individual. But this is common across all NTU courses. So should you not choose aerospace engineering any courses, you will still have to do this common core. Foundation core, this is more towards building up the foundation for your specialization. You're doing aerospace engineering, so therefore this builds out your foundation. This includes things like physics, mathematics, and all sorts of engineering skill sets that will train you. Then broadening and deepening electives. This is the one that I mentioned. Should you choose to do a major or minor, you will actually take these courses to do that area. If you want to do a minor in business, you do your electives in business. If you want to do a minor in sustainability, then you do all these electives in sustainability and so on and so forth. Okay, but should you choose not to specialize, then you can also take this and do other things. There are many electives. People can learn languages. There's also sports. For instance, people can do an elective in badminton. They can do an elective in forensic science and all sorts of things that you can try. Okay, this is for polytechnic students. Direct entry year 2. 72% that is foundation. Sorry, major requirements. Then common core, foundation core, and then the BDEs. Okay. Now, besides the curriculum that we educate you, sorry, give me a minute. Apologies. Our students will have to go through an internship program. So meaning to say, in your year 3 or year 2 of your studies, you will be going outside to do your internship. So internship will be half a semester for JC students. For poly students, it will be around 10 weeks. For JC students, 20 weeks. For poly students, 10 weeks. And the university will let you see what companies are available and you can choose. So you don't have to search for it, but if you want to search, it's up to you. But university will provide a list and then you choose the companies that you can go to do internships. And this is pretty much very valuable information. The main reason is because um, you get to know what industry is working on. And for most students, you get to run away from studies for half a semester. That's also a good thing. And also one thing to note is that it lets you decide if that particular industry or that particular company's nature of work is suitable for you. So say for instance, I have students who actually work in who after who I think in the third year went on to a manufacturing company who does some manufacturing of I think was some IT components. Then subsequently he said, hey, I really don't like the industry. So that made him know that eventually when he goes out to work, he will not do an internship. He will not choose a company that does manufacturing IT components. Okay. Now you must wondering, how can aerospace engineering go IT components? In internship, there is no need for you to go into specifically aerospace engineering. You can choose any kinds of internship you want because it's for you to experience working industry. So it should be something of your own interest. Where people who join companies for consultancy, some students join for research, for some even go to some business, some going into other stuff. But majority of them will go into aerospace engineering companies or mechanical or really just an engineering firm to experience engineering in general. Okay. So some companies out there spoke a lot. For instance, you talk about this is a engine, this is an aircraft. Number 9 is a aircraft engine manufacturing repair and overhaul company. We have A-Star that is actually doing research. We have doing a lot of things. Rolls-Royce, Pratt & Whitney. In fact, the 3 big engine manufacturers, Rolls-Royce, Pratt & Whitney, General Electric, are all in Singapore. Rolls-Royce does manufacturing of the turbofans. General Electric does the manufacturing of some of the engine components. Pratt & Whitney as well. So all 3 of them are actually doing quite a bit of work in manufacturing. MRO, they are doing more on MRO, maintenance, repair, and overhaul. And that is where the most of the revenue comes up. Now I want to share a little bit. In Singapore, our industry is mainly on maintenance, repair, and overhaul. Later, I'll have a slide to actually talk more about MRO, but just keep in mind that our industry is predominantly MRO. Now, besides internship, students will have a lot of opportunities to go overseas for internships, for internships as well as exchange programs. Exchange programs meaning to say that you spend 1 semester in an abroad university, you take their curriculums over there, and subsequently you transfer the credits back to NTU. So say for instance, coming semester you are supposed to take subject A, B, C, D, E. Then subsequently you go to that university overseas and then you take those subject A, B, C, D, E, and then you transfer back the credit, transfer back the marks to NTU. So our students have gone a lot of places. In fact, a lot more than what you see over here. For instance, the US, the top universities, for instance, in Georgia Tech, Michigan, these are world renowned in terms of aerospace. Embry-Riddle, world renowned in aerospace as well. We also have the Iowa State Rensselaer. This is also very famous. Okay, this is a very old university, very, very famous. You may not know it very well, but this is very famous. Iowa State. In the UK, University of Glasgow, Strathclyde, Sheffield Imperial College. In Netherlands, Delft. This is in Spain. We also have KTH, Sweden, Czech Republic, Warsaw. Closer to Asia, we have people going to KAIST in Korea. We'll go to Tokyo, Hong Kong Polytechnic University, HKUST, Hong Kong University of Science and Technology, as well as in China, Shanghai Jiao Tong. Shanghai Jiao Tong is very well renowned. India, IIT Bombay, IIT Mumbai, as well as in Thailand as well, Chulalongkorn University. Okay, quite a bit of students like to go to Thailand. Main reason is because for university students in Thailand, they wear school uniforms. So they think that, wow, very nice. You can still wear back school uniform to go to university. So Chulalongkorn University in Thailand, they still require students to wear uniforms. Okay, but one thing to note is that I would encourage students, should you be financially capable to go for exchange programs, for the main reason is because it allows you mobility, allows you to learn independence, allows you to experience studying in another environment. And it gives you another certificate in your CV. I give you an example. Last time when I did my undergraduate studies, I went to Georgia Tech. And when I went to Georgia Tech, I scored all A's coming back at Georgia Tech. All A's and one B. Yeah, don't want to say the B. So I used that certificate or that transcript. It wasn't a certificate, but it was a transcript of grades in my job application. And it actually, in my job application as well as a PhD application, and it helped a lot. The main reason is because it showcased that you are not just good in your home university. Let's say, for instance, you are very good in studies in your home university, but then when you go to another university that's in the US, you're as good. You scored very well. So it shows that you are very flexible. It shows that your capabilities is actually proven not just in your home university, you're proven overseas as well. So having an exchange program experience does help in a certain context. Okay, but it is not the major determining factor as well. Okay, there are many other factors that comes in to make your CV look good. For students who are interested in research, okay, we give all students the opportunity to experience research in the sense that if you're in your year 2, year 3, should your academic standing be good? If I'm not wrong, it's 3.5 upon 5, your GPA is 3.5 upon 5, you'll be invited to do research. So what do you mean by research? This Eureka undergraduate research on campus that you see here is that all students in NTU, or rather all students in aerospace engineering, will have to do a final year project. So in your 4th year, you need to do a FYP. And this is a research project. So in your 2nd or 3rd year, we actually invite you to start off testing out what research is, gain some exposure to research, how that is it done, what are some of the topics out there, you can find your interest, then subsequently in your final year, then you can choose something that is more aligned to what you want to look for. So this is something which students do feel beneficial, okay? And it's 4 AUs, and pretty much I would say it's a pass or fail. So students like to take this up mainly because it doesn't count to your GPA grades, it doesn't affect your grades, and it's 4 AUs gone for your syllabus. So besides Eureka, our curriculum also enables you a lot of hands-on. So the main thing about NTU is that we focus a lot about hands-on engineering skill sets. We are very closely related to industry. We have a lot of corporate labs here at NTU. Later, I'll introduce our corporate labs. So in your first year as aerospace engineering, in your first year, 2nd semester, you already have labs, where you have to go into the labs and then try out certain things, play certain things, aerodynamics, structures, just from materials, vibration, all those. 2nd year, you have your 2nd year labs. 3rd year, you have your 3rd year labs. And then your final year, should you choose an experimental FYP, then you have to do a lot of hands-on as well. So you have to really be equipped or be ready to phase up to what the industry requires of you. It's not just an academic study. So, a lot of students say, how many percentage of your curriculum that is becoming useful when you go out to work? I would say probably around 10%, less than 10%. What you learn in university can be relevant to industry. But the thing is, those hands-on that you learn will definitely come in very useful. Okay. So we have all the facilities, all the relevant resources that enables you to, that helps you to actually gain all these skill sets in terms of the hands-on culture. Okay. Now our professors, NTU's ranking is pretty high. It's not as high as our neighbor, but mainly because we are very focused in terms of engineering. So engineering's ranking in general is actually not that high, but we are considered one of the world's top when it comes to engineering. If you take a look at our professors, we have around 80 over professors. And over here, you see a lot of our professors here are actually in the world's top 2% scientists. So this is compiled by Stanford in the sense that in the world, who are the top scientists out there that is famous. You can see that their names are all here, and in fact, they are all our faculty. Most of them are our faculty. You see over here, we have Alessandro, world renowned in terms of fuel cell, not fuel cells, but geothermal in terms of renewable energy. Professor Gao Huajian, who is very famous, he have left us. Hortense, Prof. Yong is our chair. She's our chair, famous in 3D printing. Prof. Tan Min Jen in terms of concrete printing. Zhou Ku in terms of structures. Prof. Lam, who is our vice president for industry, and so on and so forth. So you see a lot of people here who is actually world renowned in terms of his top 2% scientists. I'm also here. Yeah, I'm also here. Okay. Now, now let's change gear a little bit. I think we have introduced enough about what the aerospace engineering NTU offers you. Let us take a look at what can you do with an aerospace engineering degree. What is out there for you? What is the potential for you next time? So for the aerospace industry in Singapore, we represent 10% of the global MRO. Now you take a look, Singapore's population is not even 1% of the world population. And yet we represent 10% of the world's MRO, maintenance and repair overhaul. Now, what does this actually mean? Now, when you talk about an aircraft, when Airbus, when Boeing, when Rolls-Royce and all these companies, when they manufacture the engines, the aircraft, they sell it, they may not sell it at a very high price. The profit margin may not be that high. But then they earn profit through the after-sales repair maintenance. Okay, the main reason is because after they sell an engine or sell an aircraft, every few months they have to go checks. Every few months they have to repair certain components. And all this is actually very huge revenue for them. This is a returning sales. So every aircraft they sell, they can last for 20 years. And for the 20 years, it's 20 years of business when it comes to maintenance, repair, and overhaul. And that's how all these companies gain their revenue. Okay, so this MRO business is in fact the crown jewel when it comes to aerospace. It's not about selling the aircraft, it's about the maintenance and repair overhaul that actually earns big bucks for the companies. Okay, last time when I was doing a internship with a company out there, just one small item, on the aircraft engine, it's actually costing $200 just to repair, and there are hundreds of it on the engines. And if you do the whole business, it can be in terms of millions, billions of Singapore dollars when it comes to this whole industry. Very lucrative. So in Singapore represents 10% of it. Major people, major companies, Rolls-Royce is here to do MRO, to service the region, Southeast Asia region. Pratt Whitney, General Electric, SIA, EC Engineering Company, ST Engineering. ST Engineering is our homegrown engineering company. They don't do business just for Singapore alone. They do it overseas. They have base overseas and all sorts of things, just doing repair and overhaul. Okay, so this represents 10%. So our industry is very in need for professionals, in need for people when it comes to this. It's 13 billion in terms of output. We have 130 players. All the major players you see out there are in Singapore. So this is a huge market. Okay, and there's a 6.1% growth rate over the past 2 decades. This aerospace industry is growing. It's very unfortunate that COVID actually brought down the whole aerospace industry, but ever since COVID have passed, this industry is growing very rapidly. Okay, we are ramping up very, very quickly when it comes to aerospace. And recently, in fact, today is the first day of the air show. So if you have a chance, do visit the air show and you can see how vibrant the industry is. Um, it's open to public on Saturday and Sunday. So if you are free, you can visit, just buy a ticket and then you can go there. All the major companies are here. Boeing, Airbus, although Boeing is not doing any flight tests, but the thing is flight displays, but they have their booth there. You have even Comac from China is actually here. All sorts of companies, Bombardier, helicopters, and all here. eVTOLs is here as well. Okay. So some news, some of the things you see over there, as you read the news, you see, oh, this company is expanding, that company is expanding, and that shows you the potential for the industry. For instance, in business time 2023, companies is ramping up. You need 3,000 new roles by end 2023. ST Engineering hire more than 200 more employees for GE Aviation in Singapore. So all sorts of things, ST Engineering and GE Aviation all stepping up their hiring. Now, at this point in time, maybe I want to stress a little bit. Um, we have been working in engineering fields in the industry, working very closely in industry for many years. And we know that there are up and downs in all sorts of industries. So say for instance, last time, very long ago, life sciences was sort of the hype. Life sciences was the hype. Everybody went into life sciences. All the students, in fact, went into life sciences. But the problem is, when life sciences was a hype, it was then that they needed the manpower. It was not the students. They don't need the students because the students, when they enter the university for life sciences, they graduate 4 years later. But the thing is, the industry needed life sciences at the point in time. So after the students join life science, they graduate 4 years later. The roles in life sciences are almost filled. And that is where the industry starts to go down, or rather starts to stabilize in a way. So there are industries that's actually hype. For instance, life sciences, now we have AI, you have all these things that has a hype at a certain period of time. Now, then subsequently, because you do not graduate now, you graduate 4 years later, you do not know what the industry is like 4 years down the road. So to a certain extent, if the industry still maintains, it's good, but if it doesn't maintain, then the industry will become very saturated with this kind of manpower, because every university now is trying to boost their headcount to actually fill the gaps, but we do not know 4 years later what do we see. Okay, in fact, if you talk about some computer sciences, we do see some saturation in terms of some industry, some companies when it comes to computer science, because this computer science trend has been there for, I think, over the past few years already. So we are actually quite saturated when it comes to this. But it is still a needed industry because we are moving towards it. At some point in time, it will stabilize. But what I want to say is that as a student, you should choose a module, or rather choose a major that is what you like in general, okay? Because you're going to study 4 years, choose something that you like, choose something that you enjoy. Then eventually when you go out to work, you can actually move, continue working on that. Or should the opportunity comes in terms of computer science, then go to it. Okay, I give you an example. I have students who actually graduating last year, previous years. They study aerospace engineering, but then when they came out of aerospace engineering, they chose to go into computer science. Why? The main reason is because there were a lot of jobs out there. There was a hype there. But why are they able to do it even though they study aerospace engineering? Is because engineering degree is, I would say, a generic degree. Okay, we train you skill sets in terms of all the fundamentals. We train you skill sets in terms of coding as well. Okay, and coding in terms of application in specific areas. Computer science teaches you really what is the meaning of coding, what is the meaning of this. It goes into very deep, but we don't go into that deep. We go into how do you apply it, how do you use it, and that's what industry requires, because industry needs to use it to make into products. So to a certain extent, they are able to transfer their skill sets to go into computer science. and you go into whatever trends is out there that is hype, or rather what is in demand in industry at that point in time. Okay, so my point is, choose something that you like, choose something that, or rather an industry that will stay on. For instance, you talk about mechanical engineering, you talk about electrical engineering, you talk about civil engineering, you talk about aerospace engineering. These industries will continue. It's stable. It is the hype is very long ago, but it's now in a stable form, whereby if you go out, you will definitely have jobs, because that's the industry they will require people in this area. And this is a stable industry, very traditional industries, whereby it will constantly have jobs for you. Okay, so that's my point I want to stress. Go for something that you like, go for something that's stable, go for something that by you are able to enjoy. Eventually, when you go out 4 years later, or maybe 3 years later, there is a certain hype in a certain area, you are still able to ride onto it, because our engineering degree in NTU is actually flexible, allows you to move into certain areas. Okay, so our students are not just students, they are actually doing a lot when it comes to international platform competitions. For instance, we have our students who participated in Dyson Award, runner-up. Uh, Muizu, who actually filed patents, during his studies, he had patents, he invented something and then subsequently patent, and then uh, that is going to follow him throughout his whole life. It can help him in terms of his CV. Laya, who actually won the National Geographic Young Explorers Award, got a grant. Zuin, who actually won the S Lifesavers Innovation Challenge. So a lot of students are actually participating in many competitions out there to actually earn competitions. So now I want to highlight one thing is that in NTU, or rather in general universities, of course, NTU will actually do a lot more for you in the sense that, or rather MAE, our school, is that we support students to go out for competitions, because it allows you to gain exposure. It allows you to boost out your CV a lot. And of course, to a school's context, it boosts out our name. So that's why we support. If you go out for competitions, our school will pay for your airfares. Of course, you need to fund a little bit, but we'll pay for airfares. And we do encourage you to join international competitions as well, because international platforms will give you a lot more exposure. Okay, so do anticipate it. In terms of aerospace, we have the design, build, fly. We have the SA Singapore. I think it's a amazing SAFMC or something like that. I think I forgot the name already. Uh, the Singapore competition for aerospace, the drones and the aircrafts. So besides students competition, our school has a lot of corporate labs. When I talk about corporate labs, I mean companies coming in to NTU, they're seeing the value of the professors in NTU, they're seeing the level of facilities that NTU can provide, the engineering experience, the research experience that we are able to contribute. And then these companies pump in money to NTU and say, let's do research together, such that my company can grow. So say, for instance, this ATMRI, Air Traffic Management Research Institute, Civil Aviation Authority of Singapore, CAS, they saw that, hey, NTU actually has the relevant expertise. NTU has the facilities. NTU has the knowledge in doing this. They pump in a few $100 million into NTU and said, let's do a research together. So we have a ATMI, Air Traffic Management Research Institute in Singapore. In fact, in NTU, during open house, should you visit us, you will be able to see a control tower. In NTU itself, we have a airport control tower within NTU, whereby it allows students to go in and experience controlling aircraft, to learn how to control aircraft. And it's part of their labs. So Air Traffic Management Institute does that. They also do in the regional scale. How do you manage traffic, aircraft traffic more effectively? For instance, Singapore's traffic, once it takes off, aircraft takes off, it goes right into Malaysian airspace. It goes into South China Sea. There'll be a lot of congestion. So how do you manage? How do you schedule aircrafts? How do you move aircrafts around such that they can save fuel? They spend the least amount of time in the air. When they come to land, there is a space for them to land, so on and so forth. How do you avoid them intruding each other's route and so on? So there's a lot of learning, a lot of research that's been done in this institute. And if you are interested, you can do a year 2, year 3 research with them. Year 4, you can do a final year project with them. Okay, so all these corporate labs is here. Singapore Center for 3D Printing. In fact, we are one of the world's leading when it comes to 3D printing. We 3D print a lot of things. For instance, we 3D print buildings, okay, 3D print concrete, we 3D print polymer, metals, titanium, aerospace components, we 3D print cells, even cells, we 3D print skin, we 3D print um, circuit boards, and all sorts of things. If you talk about anything 3D printing under the sun, we have it here. And we have a lot of companies that participates with us. For instance, ScamCorp, for instance, HTX, for instance, DSO, all sorts of companies, ST Engineering, all sorts of companies come to NTU when they have problems when they 3D print, or rather they want to find ways to improve or change their current form of manufacturing to 3D printing. So they come to us and then we do a research together and they pump in money. So when companies come to us, they don't just come and say, hey, let's do a research together. They have to pump in money, few $100,000 and say, NTU, can you do it for us? And NTU say, okay, with this money, I can buy materials, I can do it, and then I can use it to cover my overheads, electricity, all these things, and then subsequently, let's do a research together. So companies don't just come up money just out of the blue, only when they trust you, only when they see value in you, then they pump in money into your university. So that's where our value is. Rolls-Royce Corp Lab, as you know, we have our Rolls-Royce Corp Lab that's with us that does a lot of electrification of aircraft, that does a lot of research in terms of engines. Okay. Now I want to highlight one thing when we talk about electrification is that moving forward, in terms of cars, we have now moving from all those combustion engines, we move into electric aircraft, electric cars. Same thing for aviation industry, we're also moving from combustion engines using fuel to using electric aircraft. So that's where we have eVTOLs, okay? Electric vertical takeoff and landing. So there's like helicopters that is powered by electricity, okay, powered by batteries. And just last year, NTU is being awarded a huge sum of money by the Singapore government to develop electric aircrafts. Okay, so should you join us, you will be able to see this happening. You want to do a research project, you want to participate in this, you are free to participate in this, in building an electric aircraft that is the first in Singapore. Okay, so these are opportunities that you see when you join NTU as an aerospace engineering student. So there's a lot of student life in NTU, and not just in NTU, in MAE particular. MAE, we have 2,000 over students. Every year, our intake is around 500 plus for ME, 100 plus for aerospace. And in total, we have around 2,000 plus students. And we have our own clubs where we support our own clubs. For instance, our own mechanical aerospace club. We have our own aerospace society that's open to everyone in NTU. Everyone has interest in aerospace can join the club. Robotics club that is mainly focused on MAE side. Leadership development program as well as our MAE ambassadors who is helping us to do outreach programs. So all sorts of programs, all sorts of activities for you. I would say that as a student, don't just study, join CCAs, get yourself exposed to different parts of different kinds of life, know people, okay? Eventually it will help your CV, okay? Eventually it will help, definitely. Okay. So many companies, as I mentioned, our students, after they graduate, these are all the companies they join, okay? You can see over here, some aerospace companies, ST Aerospace, SIAEC, Rolls-Royce, Air Force, CAS, Pratt Whitney, okay? But a lot of them are also going into other companies, global foundries, okay? Chip manufacturing, this on chips. You can see Continental, that's on tires, there's a lot of aircraft components as well. Halliburton, oil and gas, okay? Singtel, yes, you know what Singtel does, huh? HP, okay? Dell, you see Samcorp, that's marine. Singapore Power, DBS Banks, Dyson. You see all sorts of companies out there that they take NTU aerospace engineering students as well as mechanical engineering students. Why? It's because the skill sets that we train allows you to go into these companies and they see value in terms of our students. Okay. I want to highlight that most engineering degrees are generic degrees. If you talk about aerospace, you talk about mechanical, talk about triple E, you talk about civil, talk about uh all these different courses, they are generic degrees, meaning to say that if you go out, you have a position, let's say in global foundries, they will say, hey, as long as you have an engineering degree, we'll take you in. Because what they need is the critical thinking that we train, is the kind of skill sets that we train you. Okay. But you may have an additional advantage when it comes to mechanical companies as well as aerospace companies. But then it doesn't give you a disadvantage if you go for a non-aerospace or non-mechanical company. It doesn't put you to a disadvantage. Okay. So that's what I want to say when it comes to companies. You can see our students goes everywhere. Okay. So be interested, what is the gross salary? 4899, it's constantly growing, inflation going up, your char kway teow is getting more expensive, your cup of tea is getting more expensive. So uh the salary is rising. Now the green gross is actually 4899, 4900. And this is the grade profile for A levels as well as polytechnic students. For the 90th percentile is all A's. For the 10 percentiles, you can see CCCC and CDDC. For Polytechnic, that would be 3.94, 3.91, 3.69, and 3.39. So when we talk about 90th percentile, it means that if you rank the students in terms of grades, so at the 90th percent, what is the grade? At the lowest 10%, what's the grade? So these are the representative grade profile that we actually see over here. Okay. So that's all. And I will hope to see you guys in aerospace engineering. Uh, any point in time, if you have any other questions, feel free to reach out to my colleagues. Or if you have more specific questions to aerospace engineering, you can drop me an email directly. My email I can type in the chat now. Should you have any questions, I will just type in the chat now. Uh, you can just email me. But these are more specific to aerospace engineering. If you have more towards emissions, all these questions, I may not be able to answer that well. I will have to refer you to someone else. But more on engineering, more on focused questions, I will be happy to answer to any questions that you have. Okay. So yeah, I will be here. I think we have a Q&A now. So yes, please
Yeah, all right. Thanks, Prof. Ng, for that wonderful sharing. So right now, students, if you have any questions, just feel free to just put it in the chat, and then we will just take your questions one by one, if any. So far nobody asked. So I think your presentation was so good, Prof. Ng. So everybody was
I
just
think well,
mesmerized by the prospects of aerospace engineering. I myself want to, well, if I could go back in time, I'd go for aerospace.
yes, that's great. That's great. You can always do a second degree. We welcome you. Okay.
Fantastic. Okay.
Uh,
We have one question coming in from VPin. Hope I got your name
okay.
correct.
Yes.
The IGP profile for A-level candidates was mentioned. What about for IB candidates? This is more administrative. I'm not sure whether Prof. you would know.
Okay. For IB
Yeah.
candidates, this is a very common question. IB candidates is being viewed on a separate sort of entry system.
Okay.
This one is we do not have the exact grade profile for entry. Um, I believe every year it does fluctuate also, just like what the A levels as well. But I encourage you to drop me an email. I refer you to my colleagues, or rather you can drop uh our school email. We'll refer you to the relevant people who will advise better for IB, because every year IB takes up a very small percentage. So that is why we don't have that numbers.
All right. We'll just drop in our email. You could just drop us that if you want to find out a little bit more. Okay. You could just drop to, I believe it's MAE_outreach. My colleagues will just be helping to put that in the chat.
MAE
Okay, any
underscore
other
outreach.
questions? And of course, if any of you you have to head off, please do not feel the need to stay. All right. So you may head off if you need to, if you have other appointments, etc. All right. One more question coming in from Si Jie. Is it more recommended to take out specialization in year 3 or 4, or try to apply internship? Rafeng.
Okay. Um, Oh yeah, sorry. I typed a email there. There shouldn't be an underscore. There should be the MAE outreach. Okay. But
Okay.
if you have any problems, the easiest that you want to go for is ask MAE. I think this is
Yes.
the easiest. Ask MAE.
Yep.
ASKMAE at NTU. This is the easiest one that you go, because that is our main email, and then we just filter for it. Okay. the question about recommended to take specialization in year 4 or try to do some internships. Okay, now you are already having an internship that's mandatory in year 3. So you already have one experience in terms of internship. So to a certain extent, having one internship, having two internship doesn't really make much of a difference unless you're saying that that internship that you're going to do the second one is going to be vastly different from what you do in the first one, such that you can give you additional exposure into different areas. It adds on a different skill sets to you. Okay, so let me give you an example. If you first one you go into aerospace engineering company, second one aerospace engineering, third one aerospace engineering, all your internship aerospace engineering company, then it makes you a very good aerospace engineer. But if you were to do an internship in probably a separate, maybe computer science, then it gives you additional skill sets. Eventually, when you go out to work, it helps in terms of CV because you have the additional skill sets with you. So unless you really want to really experience something new, or really you want to carry on working, experiencing more about working life, then go for internship. But then specialization, it helps you to a certain extent because if let's say for instance you want to go out to work, you want to find a work in um maybe environmental firm or maybe in the marine industry, then having a sort of a sustainability specialization will help you in a certain context because the marine industry is going to a lot of sustainability. Okay, if you want to go into uh uh maybe data science area, then maybe having a specialization in data science will also help you. So I would say I wouldn't say I wouldn't favor one over the other, but I would say it really depends on what you want to do next time. If you choose to go into a specific area, like data science, then go for a specialization in data science. But if say there's a company out there that offers you internship in data science, then go for the company for internship. So my preference is internship should come as a priority before your specialization because internship is more valuable. I hope that answers the question. Okay.
Hey,
Uh,
great. We have one more question from Natalia. Natalia asks, how much flexibility is there in this course? If the first year is mostly fundamentals, is it possible to change trajectory? Example, to other kinds of engineering. I believe she's asking after the first year if she finds out this is not for her.
okay. Um, Changing of course within university, it's very common. Okay. I myself have changed courses. I have even changed university. I was from NUS in the past, and then I changed to NTU. So changing of course, it is not difficult. Okay. But the thing is about if you are local, you have your government subsidy. Okay. How will your subsidy, what will happen to your subsidy? So meaning to say, once you change course, if I'm not wrong, then your new course, you have to do another, you start from ground zero. Then your government subsidy for 4 years, then your new course, you may not be subsidized for all 4 years. So there may be some trickiness when it comes to the government subsidy. But don't worry, that shouldn't hold you back because that is your whole 4 years, that's your career. It shouldn't hold you back. Okay. Now, um, changing our course from aerospace out is not an issue. We have students who change from aerospace to go to computer science, to go to mechanical engineering, to go to other courses within NTU. So changing your courses within NTU is not an issue because you are already within inside the university already. Then moving you around is possible, but you need to fulfill certain GPA. Let me give you an example here. Okay, you finish your first semester and then you scored A for all your subjects. Okay, you said, I don't like this course, but you still scored A. I don't like this course. I want to go into computer science. No problem. Computer science will take you because you have proven that you're a good student. Computer science will take you over. You finish the course in aerospace engineering in the first semester, you get all D's or all C's. Will computer science engineering take you? No, because they see that, hey, you have problems adapting to university. You are not a good student when it comes to university. Although you may be good when it comes to JC, when it comes to poly, but when it comes to university, you have not done well. So computer science will not take you in. So to change course, it is possible, not an issue. It is just whether you do well in university in your first semester, even before your first semester. Let's say, for instance, you don't go for exams. Before your first semester, you want to change course, no problem. That one even easier, mainly because they have not seen your university grades yet. They are using your JC grades in terms of changing. So when you want to change before you even go for exams. First semester, halfway through, maybe before exams, then you change. That is possible. Okay. Now, one more thing about it is also, if you want to change course, it also depends on the vacancies. Okay. Let's say you want to change to mechanical. Is there vacancies mechanical? Is there vacancy in in computer science? Okay. So that's where you need to choose. We have a lot of students who knock on our doors who say they want to change into aerospace engineering. I still remember there was one student who went to computer science, keep wanting to come to aerospace engineering. He says that he still likes physics, he still likes physics, he wants to come in. But then the thing is, at computer science, his GPA is only 3.3 or 3.2, very low. So as a result, we couldn't take in him because our cutoff, when you talk about aerospace engineering, you want to change to aerospace engineering, you must have 4 and above. Okay, then we allow you to change over. And also depending on whether we have dropped in terms of vacancies. Now, that means to say that there must be a student who goes out before we take you in. So there's a lot of factors that comes into play when it comes to this context. When you want to go out of MAE. But should you choose to drop from aero to go to mechanical, no problem. This one, any point in time, you can drop. But if you want to go from mechanical to aero, no, not possible. Okay? Unless you meet a certain GPA requirement, then we'll allow you to go into aerospace. Okay? So the key thing, as I said, many factors you need to consider. Financial, number one, vacancies, the time whereby you choose to change course, the GPA, should you have taken the exams, these are all factors that you need to talk about changing course. So it is not a trivial matter. It's something that you need to think through very well. Okay.
Okay, great. Thanks for the response, Prof. Ng. Our time is almost it's about 12, but we'll take one or two more last questions. Is that okay?
Yeah, yeah, sure, sure,
Yeah.
sure. Any point in time, you
All
can
right.
go past 12 is also okay.
Okay, sure. Prof. Ng, will stay here to be answering all of your questions. So I want to take the question from Melvin. Melvin asks, so can I ask, is aerospace engineering a very math/physics intensive course?
To a certain extent, um, the physics is, the mathematics, I would say moderate. Okay, mathematics moderate. We are not a mathematics major. You're not doing a physics major. You are going to use mathematics and use physics to apply it on aircraft. Okay, let me give you an example. Okay, let's say for instance in your JCs you learn things like algebra, you learn things like matrices, multiplication, all these things. And then if you go for mathematics course, it will go in depth into what is the history of it. How do you do matrix multiplication more effectively? How do you do matrix multiplication that is maybe of a certain skewness here and there? So looking into the mathematics fundamentals. But no, we don't do that. We use whatever things that's developed. For instance, matrix multiplication is just this times this. We just use it. And then we apply it to aerospace. We solve engineering problems because that's where the value is. That's where, eventually when you go out to work, you need to use this and then make an aircraft fly. You need to use it to design an aircraft. Physics is the same thing, okay? You learn about, say, uh, momentum. Let's say, for instance, momentum, two objects hitting each other and then one causes it to move. Okay, A hits B and B moves. So you don't go into the very, very fundamentals of it, but you know the phenomenon, you know the equations, and then you apply it. Okay, so to a certain extent, yes, you need to know physics and mathematics. Is it very intensive? I would say it's moderate because we don't go deep into physics, mathematics, but we need to apply it. So you need to be at least good in terms of these two portions. Okay, cool.
Okay, one more question from Ting An. Ting An asks, you mentioned a specialization in data science just now. So is it available for aerospace? Because I didn't see it in the slides.
Okay.
Specialization in data science, is it?
Specialization in data science. Give me a minute. I think you guys can still see my slides. Okay.
No, it's not
Yeah, okay.
shared anymore.
Oh, it's not shared anymore.
Yes.
Okay, give me a minute. Oh, Zoom, right? I went to Teams. Uh, okay, yeah, yeah. So I think you should be able to see my screen now. Specialization in data science, no, there isn't specialization in data science. But if you are interested in terms of data, then I would say in terms of autonomous system as well as smart manufacturing and digital factory, this has data inside. Because when you talk about digital factory, this is about digitalization of the factory floor. How do you do a sort of a mock-up? How do you do a digital twin of it? So it requires data. Collect data and then you build a twin. Autonomous system also collecting data because you need to know whatever thing that's going out there in terms of the autonomous system. You have sensors, you sense the environment, then you collect the data, and then you have a computer system to compute the decision-making process, and then you take on the next step of approach. So autonomous systems and digital factory have actually a certain level of data science inside. Yep.
Okay, hope that answers Ting An's question. There's no other questions. Just gonna give you guys maybe just a couple
Oh,
more
there is a
seconds.
question, I think,
Ah,
on Chino. If we join mechanical engineering first year, after that can change to aerospace engineering.
uh, okay, yes.
This one, we have students who does that, but you can, there are two things that I said. First thing is there must be vacancy in aerospace. The second thing is your grades must be good. Okay, you must have proven that you have done well in mechanical engineering that will allow you to change to aerospace engineering because the intake or rather the cutoff for aerospace engineering is higher.
Yep.
So therefore you need to account for that. So it is still possible. Not say 100%. You need to see various conditions met then before we can actually change you.
Okay, right. If no other questions, I think just want to highlight again, you may drop an email to Prof. Ng if you would like to. He has already given his email earlier on. Let me just help to resurface that over here. Hang on. So for everyone who has, I just can't copy. Actually, it's just oh, I can't copy and paste. But
I
it's
will
okay.
just type. I will just type.
You can just type it again for everybody. Thanks, Prof. Ng. Okay, so if not, thank you so much for coming out today morning. Feel free to drop any other extra questions to Prof. Ng if you have any course specific to aerospace engineering. And if you have any other administrative questions, you may drop an email to MAE Outreach or ask MAE at ntu.edu.sg and we'll just answer you there. Okay? So if not, have a good day ahead, everybody. Thank you all for coming up.
Okay, take care, everyone.
Take care.
Bye.